Good morning, all. Today we discuss the applications of vectors in physics. The term displacement is familiar. We can distinguish distance and displacement. We know that displacement is a vector quantity. Now we discuss about the displacement in connection with the topic vectors. We consider a three-dimensional space for our description of position and motion. To set up some position, we need a coordinate system. A coordinate system that is familiar to you is three-dimensional Cartesian coordinate system with axis x, y, and z. That is given in the figure. Here in the figure, we marked the axes by 1, 2, 3, 4, etc. for our convenience. For our discussion, our aim is to measure position. We know that the unit of distance or displacement, we take it as meter. It is the standard unit. SI unit of distance or SI unit of length is meter. So we consider the axes are labeled by some numbers. Let it be in the unit of distance, unit of length. How can we locate any position? If we have a point P or anything, then in the three-dimensional coordinate system, we say that it has the coordinates or it has the values, component values x, y, z. Here we take 2 points. Let it be another point. First point, let it be that is with x1. The point is represented by x1, y1 and z1, and the second point is, or the second position is represented by x2, y2 and z2. We take the coordinate system, three-dimensional coordinate system. Here, the two positions with coordinates x1, y1, z1, and the second is with x2, y2 and z2. If these two points are connected by some vector, what we call it? It is the displacement. Displacement is the straight line distance between 2 points. Then we take 2 points, then the length between, or we draw a vector from the first one to second one. It must be the displacement vector. Let it be vector S, or it is the displacement vector. And so it must have the components. If the vector S is defined as, if our vector S is defined as the vector S is equal to x xi plus sy j plus sz k. It is the displacement vector, and here we have these 2 points. Then the component of the vectors must be equal to Sx must be equal to x2 minus x1, and Sy must be equal to y2 minus y1, and Sz must be equal to z2 minus z1. Is it clear? Then S is called as, it is the displacement. When we defining a displacement vector, we take its arrow heading from initial position to the final position. As S is a vector quantity, the direction is very important. Here we denote its direction is from first point or the initial point to the final point. Is it okay? Then here consider a point P having coordinate x, y, z. Let it be any point P having coordinate x, y and z. Here we discuss about only one point, and x, y, z is our coordinate system. Here look at the figure. It is our point P, its coordinate x, y, z. Then it is possible to describe the position of the point with respect to origin of the given coordinate system by a special vector that is known as position vector. Position vector means it is a vector associated with some position or some points. Or we can say that it is the vector drawn from the origin of the coordinate system to the point. The vector starts from origin and ends at the position or that point. So associated with any position, there must be a position vector. Here, the position vector associated with this point P is represented as R, small r. We know that in the printing, we only use the bold letter R to represent the vector. If we write in our notebook or anything, if we write, we use R with a arrow. It is the R vector. Then what will be the position vector R? Here we know that the coordinate of the origin is 0, 0, 0. Okay. Then compare with the previous case. Here there are 2 points. First point is 0, 0, 0 and the second point is x, y, z. Then we set the coordinate in the previous slide, that is x must be equal to x2 minus x1, sy must be equal to y2 minus y1 and sz must be equal to z2 minus z1. Here the second quantities or the first quantity, it may be anything. Okay, here the origin coordinates are 0, 0, 0. So here our first coordinate x1, x2, x3. Sorry, x1, y1, z1. x1 first coordinate is x1, y1, z1. Second coordinate is x2, y2, z2. Here all our first coordinates are 0. Then the r vector can be written as r vector is equal to xi plus yj plus zk. We can represent the position vector r is equal to xi plus yj plus zk. So for every position, there is a position vector associated with it. Okay. But this position vector depends we know that we write for the position vector r, that is equal to xi plus yj plus zk. We know that here x, y, z are the coordinate from the corresponding coordinate system. Okay. Then when we taking another coordinate system, okay, let it be a Cartesian coordinate system with some other axes. Let it be x dash, y dash and z dash as the axes. So for our point is our point P is represented using this coordinate system. Here our coordinate system is xyz coordinate system. In this coordinate system, P is represented by xy, P of xyz. If the P is represented in another coordinate system having the axes as x dash, y dash, z dash, then the corresponding coordinate must be x dash, y dash, z dash. Okay. Consider as this one. That is here two coordinate systems. The first coordinate system is our previous one xyz, and the second coordinate system is x dash, y dash and z dash. Okay. What is a position vector? Position vector is a vector drawn from the origin of a coordinate system to that point. Then look at here. Here, this is the position vector in this coordinate system, and here this point is drawn from this coordinate system. Here it is the origin of this coordinate system. Then we drawn a vector from here to this P, that is labeled as R dash. In first coordinate system, we labeled it as R vector, and in the second coordinate system, from this second coordinate system, we represent it as R dash. Okay. Then we also draw another vector, that is from the origin of first one to the origin of the second coordinate system. From the origin of first coordinate system to the origin of second coordinate system, that is from this point to this point, that is labeled as R. From here to here, arrow N here, and R dash is from origin to this point and R is from origin of this to that point. Then what is the relation connecting these these quantities? That is, we have three vectors. First is R and the second vector is R dash and the third vector is capital R. Look at the diagram. We know that this arrow end here and tail start from here. This is R dash. Then using the addition of vectors, we know that this small r vector can be written as R dash plus capital R. Okay. So we write the expression for R dash as R dash must be equal to R vector minus capital R. Okay. It will be clear from the vector addition. Here we can write it as, using vector addition we can write R vector capital R vector plus R dash vector, that is equal to what? That is equal to small r vector. Then R dash vector must be equal to small r vector minus capital R. Okay. Here we pointed that the position vector depends on the coordinate system. Position vector depends on the coordinate system. Okay. But a true vector such as displacement, that is independent of the coordinate system. Position vector that depend on coordinate system, but displacement is also a vector, but it is independent of coordinate system. We have to verify it. Consider the figure. Here, as in the previous case, first we take a point, let it be P1. Okay. Then this P1 is taken from the first coordinate system, that vector, let it be the coordinates of P1 as x1, y1, z1. Okay. Then we draw a position vector, that is r1 vector, that must be equal to x1i plus x2j, sorry, x1i plus y1j plus z1k, x1i plus y1j plus z1k. Okay, here the same point P1, it is represented using the other coordinate system, that is P1 represented from the primed coordinate system, that is x1 dash, y1 dash, z1 dash. Then the vector is represented by r1 dash is equal to x1 dash I plus y1 dash j plus z1 dash k. Is it okay? Then this point is represented using this coordinate system. Okay, that is r1 dash. First is r1, and here it is represented using the another coordinate system. And the next point, let it be that point be any another. Let it be, here the point is P2. The point P2 is also represented using the first coordinate system, that is R2, and the using the second coordinate system as R2 dash. Okay. And here also we draw a vector from the origin of first coordinate system to the second coordinate system. Okay. Then for S, the vector S is equal to what? The vector S in the first coordinate system will be, it is the difference between these two. Okay, that is R2 minus R1. Okay, and that is measured from this, the second coordinate system. It is equal to what? It is equal to R2 dash minus R1 dash. Okay, we have to prove that. The same S is observed from this quantity. We have to prove that. What we have to prove? We have to prove that S in the first coordinate system must be equal to S in the primed coordinate. Or if the displacement is measured from first coordinate system, must be equal to the displacement measured from the second coordinate system. We have to prove that. Okay, for that we use the definition, that is we know that R2 is equal to what? Look at this one. R2 is equal to, in terms of R, here we take this. These directions, these arrows, capital R, we know that. Here I write here capital R vector plus R2 dash must be equal to R2. R vector plus R2 dash vector must be equal to R2. And similarly, R vector plus, when we taking this one and R1 dash, that is equal to R1. Then capital R plus R1 dash must be equal to R1 vector. From these two expressions. From the first expression, we can write R2 dash is equal to R2 dash is equal to R2 dash is equal to R2 minus R. That is discussed in the previous. Then R1 dash is equal to R1 vector. Here it is also vector notations minus R. We have to substitute the value of R2 and R1 here. Okay, look at here. In the position of R2, we replace it by R2 dash plus R, and in the position of R1, we replace it by R1 dash plus R. Okay, then this R plus R and this R, this must be cancelled. That is capital R minus capital R. Then that cancels. Then what we get? R2 dash minus R1 dash. So S is equal to R2 minus R1. That is also is equal to R2 dash minus R1 dash. So the displacement is independent of the coordinate system. Then we go to the velocity and acceleration. For simplicity, we take only the motion in one-dimensional case. Now, let x be the value of coordinate of a particle moving along a line. That is, the particle is moving only in one dimension. That is, let it be in the x direction. And we take our convenience, x is measured in any convenient unit, let it be in meter, kilometer, centimeter, etc. Anything. Okay. Now we take our for our convenience, let it as meter. And here we consider the motion of a particle. So we continuously observing the positions of the particle in every time. Okay. We record the motion of that particle continuously. That is, we have a continuous record of position versus time. Okay. Then what will be the average velocity? We have a data of that particle with time and position. Okay. Then the velocity, average velocity of the particle in between two times, t1 and t2. It can be defined as it is equal to the positions of the position of that two times we have to obtain the displacement. For obtaining displacement, if it is the position for t1 and if it is the position at t2, we have to obtain this distance. Okay. For that, x of t1, it is x of t2. Okay, here we have to write here, it will be x of the position. We know that the displacement must be taken from the difference of final minus the initial. Okay, then x of t2 minus x of t1 divided by t2 minus t1, it must be the average velocity of the particle. Then what is the instantaneous velocity? For obtaining instantaneous velocity, we use the mathematics. That is known as the differentiation. Okay. That is, the instantaneous velocity is the limit of average velocity as the time interval approaches 0. Okay. Here I write v dash. The average velocity can be written as delta x divided by delta t. Okay, then instantaneous velocity v is the limit delta t turns to 0. That is the time interval approaches 0, delta x divided by, that is, it is limit delta t, or I write here, it will be clear, delta t v bar. Okay, instantaneous velocity is the limit of, it is the limit of average velocity, it is the limit of average velocity as the time interval approaches 0, or this is known as limit delta t tends to 0, delta x divided by delta t must be equal to dx divided by dt. Okay, it is the velocity. That is known as the velocity, or it is written by dx divided by dt. In a similar fashion, we can obtain the instantaneous acceleration. Acceleration is the rate of change of velocity. So, the acceleration A can be written as limit delta t tends to 0, v of t plus delta t minus v of t divided by delta t. It is the acceleration. Or we write A is equal to dv divided by dt, or it is also written as d by dt of, what is v? V is equal to dx divided by dt, dx divided by dt, or A is equal to d square x divided by dt square. Okay, acceleration can also be written as A is equal to d square x divided by dt square, or it is equal to dv divided by dt. In this session, we discuss the displacement, velocity, and the acceleration. Okay, thank you.